Okay, so I gave you guys some homework yesterday. I'm just going to do attendance real quick because we're already late and we are no question today. We're missing Angel and we're missing Danny and Cheyenne. 3 desks, is that it? Perfect. Okay, so I gave you some homework yesterday. There were a couple questions. Number 12 was one that a few of you asked about that I said I was going to go over today. Are there any other questions from the homework anyone wants to see done? Yes, sir. Number 13. After I do 12, we'll see whether or not you can do 13. Because 12 and 13 are basically the same. 12 is actually the harder of the two. So 12 and 13 are the same. Any other questions from the homework you want me to go over before I go over 12? Going once, twice. Sorry, yes, Harwin? He already said 13. And 12 and 13 are the same, so once I do 12, you should be able to do 13. Anybody else? Twice, 3 times. Sold. Okay, here we go. So this is question 12. I'm going to do it 2 different ways, gentlemen at the back, so that we can see that even though the answer key gives us one form, there's actually a couple totally acceptable forms of the equation here. So these are, and I'll make it look a little bit clearer, this is a 1. So then this is also a 1. Okay, so first things first, what do we got to do? Tell me. Yeah, in this case, there's only one denominator, so we're just going to multiply everything by it, the whole term, or the whole expression there, in the denominator to move some stuff around. So we're going to take this, and we're going to multiply both sides by 1 minus nd, and we're going to multiply this by 1 minus nd. So we're going to get I bracket 1 minus nd equals d, because on this side it's going to cancel, yeah? Yes? You follow what I did? Okay. In the blue version, I'm going to do exactly the same thing because the first step is the same regardless of the next step. The second step is where things get a little bit weird. So you've got 2 options for step number 2. Anyone want to suggest one of them? Kyla. I can divide both sides by I. That's one option. Or the other option, distribute the I in. So that's what these 2 are all about. So if I'm going to divide both sides by I, that's what I'm going to do here on the orange. It's going to cancel my i's, and it's going to leave me with 1 minus nd equals d over I. And this one, I'm going to distribute. So I'm going to get 1 times I is just I, minus ndi equals d. We see the difference here, yes? Okay. So let's do this one. I divided both sides by I. Remember, I'm solving here for n. So what do I do next over here? Yes, 10 meet. Subtract 1 on both sides because the 1 here is positive. So if I subtract 1 on both sides, I'm going to get negative nd equals d over I minus 1. Absolutely. What next? Carolyn. Subtract d? Is this one? Yeah, I want to divide by negative d, and that's going to get me n by itself. So I'm going to get n equals d over I minus 1 all over negative d, which, if I'm not mistaken, that was the answer given to you in the key. Okay, well, let's keep this party going over here. What do I do over here? Carolyn. Sorry, do what? Subtract I on both sides. Sure, I can do that. Here it's going to cancel, leaving me with negative NDI equals D minus I. And then my last step is going to be to do what? Tell me. Divide by, I want to do, if we can do it in one step, that'd be cool. I can divide it by D, I can divide it by I, and I can divide it by the negative. So I can divide this whole thing by negative DI. So I'm going to get N equals D minus I over negative DI. So that means, I mean, there's nothing I did that was, you know, mathematically untoward. So these must be equivalent. There is another thing we can do here to make our life, or to give us yet another answer. I can take this thing a step further if I wanted to, because this thing is just, there's an expression in the numerator with one denominator. So if I'm subtracting in the numerator with a single denominator, this is the same thing as a fraction minus a fraction with the denominator is the same, right? Like I could write it like this. D over negative DI minus I over negative DI. Is this and this the same? Yeah. This is just, I've got the same denominator, so I'm just going to subtract the numerators. This is just what I would get if I went backwards here. But we're going to take this a step further. Can I simplify these two fractions at all? Sorry, I mean like within the fraction itself. Like, can that fraction be simplified or reduced? Okay, gentlemen in the back. I've got a D in the numerator and a D in the denominator, and a fraction just means I'm dividing, yeah? So I've got I can factor out a divide out a D from both of these, right? We follow what I'm doing there, or is that, we're not cool with that? Yeah, Eminette? Yeah, that's all it would be. Because the D and the D, they would just cancel out. I get negative 1 over I. And then what would happen here? Minus negative 1 over D, which is just going to give me negative 1 over I plus 1 over D. So this is yet another equivalent expression. You could end up with any one of these three, and they are all actually the same thing. So, yes, in the answer key that you were given for the homework, you were only given one of them. That doesn't mean that that's the only one that's acceptable. There's a couple here that are available to you as well. 13 is exactly the same. You want to multiply by, in fact, it's even easier. You want to multiply both sides by the denominator, and then you can either distribute or you can just divide by k. Either way, you'll get one of these two styles of answer. So if you didn't get 13, I want you to, now seeing this, hopefully writing this down. I'm hoping that was the thing that was done. And if at the very least you didn't write it down, you can now see it in the video. You've got some methods here to use. Does this kind of make sense? Questions about any of this? Okay. Anyone want to see anything else? Yeah. I posted it this morning because I forgot to do it yesterday after school. Yeah, sorry. I did post it. You know, and if you yeah, email me. Feel free to email me. If you look for it and you can't find it, that means I forgot to post it. And yeah, fire me an email and I can deal with that. I recognized this morning that I forgot to do it. I'm sorry. But we'll get you caught up. This, Nika, is all just, it's the same as what we were doing before, except there's just a bunch of different variables, and we just choose to solve for one of them. So it's the same set of mathematical operations, except they're not going to simplify as nicely, because you're not going to have numbers that add together. You're going to have two variables that add, and when it's two variables that add, it'll be like n plus d. You can't make that 5. You just have to leave it as the two variables added. So the math itself, the steps haven't changed. It just doesn't clean up as nice, is what I'm trying to say. Okay. Questions, comments, concerns? Anybody else? Going once, twice. Amonette. Was that a stretching or was that a question? Sold. Okay. Then what I want you to do is I want you to find your notes, flip the page. That's the wrong thing. We'll see how far we get today. This class ends at 1:15. Is that true? Why do I have this? Okay, here we go. 1:45. Okay. Here we go. So, using formulas, you guys, we've substituted things before. We've kind of done this already. We're just going to do it again. Make sure we're cool with it. This should not take a super long time. And I'm hoping we can start the next lesson today as well. So, using formulas, it's just substitution. And we did this at the beginning of the unit. If I give you a word problem like this, and I tell you the speed of sound in water is 1,500 meters per second. The formula for the distance to an object is d equals 1,500 t over 2, where d is the distance in meters and t is the time in seconds. If it takes 0.35 seconds for sound to reach a shipwreck and bounce back, how deep is the water above the wreck? Okay, so 10 meet. What do we know? Let's strip back even further. What do we know? Sorry? Okay, we know that the speed of sound in water is 1,500 meters per second. What else do we know? Yeah. Okay. And we know one other thing. Carolyn. We know that d is the distance in meters. Oh, and we know more about d than that. We know the relationship between d and t. We know that d equals 1,500 times t divided by 2. So we actually want to know, so this is a formula that we've given. These are the pieces of information we know. What do we want to know? We want to know d. So what we're going to do is we're going to substitute and solve. We have to substitute the correct variable, so the correct value in for the correct variable. We want to know d, and we're given t, and we know the speed of sound in water. So which value are we going to have to plug into this thing? T, which is 0.35. So we know the substitute, d equals 1,500, which is what you were saying before 10 meet, yeah? And now we just have to do the math. What is the depth of the water? Carolyn.
535 over 2.
Which is? 262.5 meters. Absolutely. So then, when I give you a word problem, you always have to give me your answer in words of some kind of sentence, words of some kind. So the water is 262.5 meters deep. And we're done. That's it. This is just outlines the way I want you to think through these kinds of problems. Identify what you know, substitute what you know into the equation that you're given to solve for the information you need, and then state the result. So, let's do these two. I'll just let you do these two on your own, see what happens. In the following formula, T, the air temperature in degrees Celsius at an altitude h in meters, and little t is the ground temperature in degrees Celsius. There is the relationship. If the ground temperature is 15, what is the temperature outside an aircraft at 6,000 meters and at 3,000 meters? I want you to give these two a shot. This should just kind of be a review of what we've already looked at. On your mark, set, go. Put as much pencil paper as you can. Do as little in your head as is necessary. Write out the formula, write out what you know, plug in the values and solve. Don't do it all in your head. You can do this based on what you just saw. Try. You don't need anything from what we did yesterday to be able to do this. Can you find your mistake? You should both be. Yep. You have a real thing. Good. Good. Okay. We good? I'm not seeing a lot of questions. And you're helping each other, which is good. At 6,000 meters, what's the temperature? Negative 25 degrees Celsius. Is the temp outside the aircraft. And at 3,000 meters, what's the temperature? Negative 5 degrees Celsius is the temp. Outside the aircraft. For those of you who may be struggling, let's do one of these things just to kind of show you what happened here. I know there wasn't a ton of space. I didn't leave you a ton of space, and so I apologize for that. But basically all you're doing, once you've identified what you've been given, the formula that you've been given, which we're going to write down here as big T equals little t minus h over 150, and identified what values we've been given in the question, we know for question B here, what two values? What do we know? 3,000 meters is the altitude, which is which variable? So this guy right here is h. What else do we know? Small t is the ground temperature, and we're told that the ground temperature is 15 degrees. So we know that small t is equal to 15. We can just plug these two values in now in here and solve. So let's do it. Small t is 15 minus 3,000 over 150. Well, 3,000 over 150, if you needed a calculator, whatever, that's this here. Now it's just bed mass. We do the division here. This is going to give you 20. So then 15 minus 20 equals negative 5. And then you quote your answer as a sentence. That's it. It's just being super deliberate about identifying what you're given each step of the way. Last example I'm going to do with you guys today is this here. We want to working with formulas. There might be some circumstances where what you're looking for is not what the formula has already isolated for. For example, scientists can determine the length of a giant squid by measuring the diameter of suction pod scars left on its prey. Now, this formula here isn't accurate, but we're just going to assume it is. The formula is L equals 180D, where L is the length of the squid and D is the diameter of the suction pod scars. Question is, what is the diameter of the suction pod on a squid that is 360 meters long? Now, what is a suction pod? I will. How dare you? Here we go. So, to explain all of this, let me introduce you to a giant squid. Okay, so ladies and gentlemen, here is a giant squid. Where's a good picture? This one's not a terrible one. Okay, so this is a squid. Okay, it's not a great picture. The fake one? Oh, this one? Well, that's not a real one. That's just an artist's interpretation. Let's get a better one. Well, I guess if we want real, we could go here. Let's do this. Okay, so here's what the question's arguing. A giant squid. Squid, for those of you who have never seen squid, have these little suction cup dealies on their arms. Okay, so that's these things here. Okay, so this is a suction cup on the arm of a squid, Carmen. So what these things do, I'm getting there. what these things do, I'm explaining the question, is squid can control these. They flex, and they can hook these things onto prey or someone who's attacking them, perhaps. And then when they rip their arms off, if they're grabbed onto something, they pull their arm away. Because of the strength of the suction, they can rip flesh off of whatever they're dealing with. The diameter, see, these are all circles. Diameter is the distance across a circle. So what they're doing is they're looking at the scars of these animals. So they might go to this whale right here, and they look at the scars, because as you can see, this big guy eats this big guy, and in an effort to not die, this thing attacks this thing with its suction cupped arms. So they go and they look at the whale and they say, okay, well, if we measured the size of the scarring on this whale, we can figure out how long this squid was. So that's what the question is actually getting at. So, according to this question, this is not a real formula, but for the sake of the question, we're told that the formula is L equals 180D, where L is the length of the squid and D is the diameter. So, what is the diameter of the suction pods on a squid that's 360 meters long? We have this formula here. We have the length is equal to 180D. And the other thing we know is that the length is what? 360 meters. This is 3.5 football fields. It's a little bit ridiculous. Hello, Rye. Okay, just one? Okay. So what do we want? What are we actually looking for here? We want D. This formula doesn't solve for D. So you got two options here. Either you can substitute and then isolate, or you can isolate and then substitute. Okay? So you can either substitute, then isolate, or isolate, then substitute. Isolate, then substitute. I don't particularly care which is which. In the interest of reviewing what we did yesterday, for the sake of today, I am going to isolate first. So I want this formula isolated for the variable we're looking for. So how do I get D by itself here? Carolyn? We're going to divide by 180 on both sides. And we're going to get then that D is going to equal L over 180. And then I'm going to substitute the value that we're given for L into this formula. So we're then going to get 360 divided by 180 equals D. So D then equals what? The diameter here is 2 what? What are the units on meters? So what they're saying is if the squid was 360 meters long, 3.5 football fields, it would have suction cups that were circles this big across. Would be horrifying. This is like the Kraken. Yes, this is exactly what this is. This is the Kraken, yeah, 100%. Yeah. Okay. So if they made squid that big, that's what would happen. So we now have to state our answer. The diameter of the suction pods would be 2 meters, period, and we're done. Cool? Horrifying, but we are done. Okay, questions, comments, concerns. This is relatively straightforward, yes? We did this in the very first lesson. Now we're doing it again, formalizing it a little bit, but otherwise it's the same thing we've already done. So, what I want you to do is this. Flip the page. I know, so sad. I want you to do question number 1. I want you to do question number 3. I want you to do 4. I want you to do 6. Yes. And in question 6, there's A, B, and a C. You don't have to do 6C. You just have to do A and B. So all of them, number 1, number 3, number 4, number 6, all have an A and a B. I want you to do all of them. It shouldn't take you very long here. So on your mark, set, go. We'll see where you're at in 10 minutes. Yeah? Yeah. If we focused a little bit more instead of messing around with people sitting around us, you should be able to get this done. Well, 6 of one, half a dozen of the other. You give it as well as you take it. And see, this is exactly what I mean. Just how about you don't talk, nobody talks to anybody except the person directly next to them? Yes. And we see how much we accomplish, Carmen. So you can talk to Nika if she wants to talk to you, and Nika only.